Here's an image of a stop sign that's viewed from an angle, and I'll show you how to create and apply a perspective transform so that it looks like we're viewing this sign from the front. Remember, we care about the perspective transform because the software we write will eventually do this to images of a road so that you can find the lane curvature. We're using a traffic sign as an example here mainly because it's easiest to see that you've performed a perspective transform correctly on images with text or other distinct reference points. To create a perspective transform, we'll first select 4 points that define a rectangle on a plane in this image. 4 points are enough to define a linear transformation from one perspective to another. And in this case, we're selecting points that define a plane on the surface of the stop sign. And we'll also select where we want those same 4 points to appear in our transformed, often called warped, image. Then we can use OpenCV functions to calculate the transform that maps the points in the original image to the warped image with a different perspective. In this notebook, I've read in a stop sign image. Here it is displayed in an interactive window. You can see that the image has been taken at a bit of an angle, and I want to apply a transform to make it look as if we're viewing the sign from the front. First, I'll manually create my 4 points on this original source image and on my warped destination image that doesn't exist yet. These points will define the perspective transform. I'll do the source image points first. And I'll choose them by looking at the x and y coordinate values for each point I want. This interactive window lets me see the x and y value of each point where I place my mouse. So let's zoom in on the stop sign to get a better look. I'll define my first point at this top right corner on the sign, the second one right to the bottom of that, then to the left of that, and finally my top left corner here. Here are the 4 xy coordinates for the points I selected. These 4 points define a rectangle plane on the sign, and I can even display them on my image just to see that they're where I want using plt.plot, the xy coordinates, and this dot character. So here are the 4 points all displayed, and they look pretty good. This was the first step, but applying a perspective transform takes a couple of steps, so I'm going to put these coordinates all in a function named warp that takes in an image and will return the warped image. So here's our warp function that takes in an image. And here are those same 4 coordinates I chose above, placed into an array of points named source for source image. Next, I'll define a desired rectangle plane for the warped image. And I'll choose 4 different points that are where I want the source points to end up. This time I chose my points by just eyeballing a rectangle in that same image and picking the 4 points that define it from the top right corner around to the top left. So these 4 points define a desired rectangle, and I'm putting these points in my warp function in a point array named dist for destination. Now that I have my source and destination points, I can compute the perspective transform, which is a matrix that's returned by the function getPerspectiveTransform. The function getPerspectiveTransform just takes in our 4 source points and our 4 destination points, and it returns the mapping as a perspective matrix, which I'll call M. You could also get the inverse perspective transform to unwarp the image by just switching these source and destination points in this function. This would just reverse the transform. Next, I need to apply the transform M to the original image to get the warped image, and I do that with a call to warp perspective. Warp perspective takes in our image, the perspective matrix M, the size we want the warped image to be, which I'll leave as the same size as the original image, and how to interpolate points, which is just filling in missing points as it warps an image, and I'll put that as linear interpolation. So this returns a perspective warped image based on this matrix M and the given image. And finally, I'll just return that warped image. Now let's see what happens when I apply our warp function to an image. And here's code to plot the original and the transformed image next to one another. So here's the original and the warped image. It looks pretty good. I can see the stop sign as if I was standing right in front of it. Now it's your turn to apply a perspective transform to a new image.